Hi everyone. Through this class, we are going to discuss about voltage controlled oscillator. Voltage controlled oscillator or VCO is also known as voltage to frequency converter. In all the oscillators discussed so far, here the frequency is controlled by RC time constant. But here it is controlled by voltage. In frequency modulation, tone generator, frequency shift keying, etc. need to be controlled by an input voltage or control voltage. So in this VCO, the output it is controlled by the input voltage. And example of such VCO is NE or SC 566. And it provides square and triangular wave outputs as a function of input voltage. The block diagram of this VCO it is shown here. It consists of current sources, Schmitt trigger and buffer amplifiers. In VCO, the frequency of oscillation it is determined by this R1, C1 and the control voltage VC given. And the triangular wave output, it is taken from terminal 4 and it is obtained by alternatively charging C1 with current source and discharging by another current source. Charge-discharge levels are determined by Schmitt-Trigger action. Due to the Schmitt-Trigger action, we get another wave output that is square wave in nature. Both these output waveforms are buffered so that the output impedance of each is 50 ohm. The typical peak-to-peak amplitude of triangular wave is 2.4 volt and peak-to-peak amplitude of the square wave is 5.4 volt. The pin diagram of NE or SC 566 VCO is shown here. There are 8 legs for this VCO and it is a dual inline pin. The first leg that is connected to ground. Second one there is no connection. From third and fourth leg we get the square wave output and triangular wave outputs. Fifth one we connect to the control voltage. Sixth leg it is connected to output resistance R1 and seventh one that is connected to output capacitor C1. The eighth terminal or leg it is connected to the supply voltage plus V. The practical connection diagram of VCO is shown here. The initial voltage at the terminal number 5 that is control voltage VC must be in between 3/4 V and V. Suppose we are applying plus V as 10 volt, then our VC should be in between 7.5 volt and 10 volt. And the output frequency given by this circuit that is equal to FO is approximately equal to 2 into plus V minus VC that divided by R1 C1 into supplied voltage V. So from this expression we can see that the output frequency that is decided by R1 C1 and the control voltage VC for a supply voltage plus V. And the value of our R1 should be in between 2 kilo ohm and 20 kilo ohm. For a fixed VC, if we change the resistance from 2 kilo ohm to 20 kilo ohm, we can vary the frequency in the ratio 10:1. In the circuit, the maximum output frequency possible for triangular as well as square wave is 1 MHz. And here in this practical connection diagram, we can see that one capacitor C2 is connected. In between terminal number 6 and terminal number 5. And here the value of this capacitor is 0.001 microfarad. That is used to eliminate the possible oscillations in this control voltage Vc. And if the VCO is used to drive a standard logic circuitry, then we must use supply voltage plus or minus 5 volt for getting proper DC level for the output square wave. VCO is commonly used for converting low frequency signals like EEG or electrocardiograms into audio frequency. This audio signal is then transmitted over a telephone line for the diagnostic purpose. Then we can record it on a magnetic tape.